So this is a video recording of lesson number 4, and what we're trying to do here is to figure out the angle if we're given the trig ratio. We've already done this in Math 10C and in Math 20-1, so this is sort of a review. The only trick is that now we're trying to do it with trig quantities, or sorry, radian quantities, as well as degree quantities. So for example, if I have the statement cosine of x is equal to negative 0.5. Well, the first thing we want to do is do a quick sketch of where this is on our unit circle. And we have our sine, cosec, tangent. So my cos is my x, and my cos is negative. So it'll be somewhere here-ish. That would be about 0.5. So this is going to be the coordinate that is negative 0.5, comma, something. Right? Now, negative 0.5 is one of my exact values sort of things. So it's going to be in quadrants 2 and in 3. Now, if I use my unit circle, I call this plane where's Waldo, because I'm just looking for where is 0.5. So if I think about my 3 lines, this is going to be 0.5 comma root 3 over 2, or 1/2 comma root 3 over 2. And then this is going to be root 3 over 2 comma 1/2. So it's going to be this point here at 120 degrees. So my reference angle is 60 degrees, but since we're in quadrants 2, the rotation angle would be 180 minus. And you can either do that or you can just look at your unit circle and go, oh, it's right there. This one here would be 60 past. This is going to be 240 in quadrant 3. Now, it's always handy to check this, so I can pull out my handy-dandy calculator here. And I can say, what is the cosine? Make sure I'm in degrees. What is the cosine of 240 degrees? Oh, look, it's negative 0.5, just like I knew it would be. What about the cosine of 120 degrees? Ha! Surprise, I did it right. Now, this can get a little trickier, because what they want here is sine squared. So we write that as this because we're too lazy to put these two parentheses. So what I actually have is sine theta squared equals 1/2. If I take the square root, I get sine theta equals 1 over root 2, which is the same as root 2 over 2. So we like writing it like this in our unit circle because it fits. Now, because it was the square root, it's actually going to be plus minus of both of these things. So I need all of the places where sine will be root 2 over 2. My reference angle for this is going to be the 45s. So I'm going to need 45 and 135. Those will be my positive root 2 over 2s. And I'll also need my negative root 2 over 2s, which is going to be 225 and 315. There we go. Now we could also graph this. This is one of my favorites. Go in here. So I would like sine of x squared. I've actually got a couple extra brackets in here that are unnecessary. Let's weed those out. Sine of x all squared, and then 0.5. Now we can graph it, and I'm going to use Zoom Trig to help me get my graph right. Now, if I change my window settings for my x from 0 to 360, and I make my scale 45, I'm going to be able to see these really clearly. oh, look, there is 45, there is 135, there is 225, there is 315. Yay! If we have the reciprocal trig function, all we have to do is flip it around. Say cotangent. Ah, what a silly question. What I actually want is tangent equals 1 over root 3. On my unit circle, there's that one, and there's this one. I need my two positive slopes, so it's going to be in 1 and 4. Slope of 1 over root 3, slope of 1 over root 3, sine, cosec, tan. So my tan is the slope, tannum. So there's that. And so this will happen when x equals 30 degrees, or 30 degrees past 180, which is 210 degrees. Sometimes these will not be exact value numbers. This one here is not an expressively nice value. So all I'm going to have to do is go secant matches with cosine. And so x equals cos negative 1. I'm going to do the inverse because I want the original input back. And so I just type this in here, use my cos inverse or arc cos button. 1 divided by 1.2631. Now you might be saying to yourself here, Mr. McManus, I'm pretty sure you mean negative 1 over 1.2631. I don't in this case. What we always want to do when we're using our calculator is just to get the reference angle. And to get the reference angle, we always use the positive value. So my reference angle is going to be this 37.7 degrees. And I need to see which quadrants I need cosine in. Cos is the x, and I need it to be negative, so I'm going to be right here. So my two angles are going to be, just store that here. It's going to be 180 minus that value, or 180 plus that value. So 142.3 or 217.7 will be my values that are good. Rounded to the nearest degree, this is just going to be 142 and 218 will be my two solutions for that one. For this one, I just rewrite this and say cosecant, no, sine x equals 1 over 2.45. Or x equals sine inverse of 1 over 2.45. Sine inverse of 1 divided by 2.45. Close my bracket, put an actual point in there. 24.1 or 24 degrees. Now remember that this is still my reference angle, and so I actually need to get both locations. Sine is going to be positive, so I draw my little sketch. Sine is the y, so in equals 6 tangent. So right there is 24, and right there also back 24. So my rotation angle, or principal angle in this case, is going to be 156 degrees. Cosine of 0, this is kind of a unit circle-y thing. You could type it into your calculator, but it'll still only give you the one value. My cosine equals 0 when x equals 0. That's going to happen right there and right there. So this is going to be 90 degrees to 70 degrees. If I really wanted to check that out, I could just rock that through on my calculator. Cosecant theta is undefined. Undefined, we just want to think about 1 over 0. So cosecant is the exact reciprocal of sine theta. So cosecant will be undefined when sine is 0 over 1. When sine is 0, sine cosec tandem. The sine is the y, which means y is 0 here and here. Theta equals 0 or 180. All right. In radians, basically the same thing. Remember that our rules here are pi over m minus 1, pi over m plus 1, pi over m, and 2m minus 1, pi over m, which is basically saying the exact same thing as this. I'm just pulling out a little shorthand there. So cosine theta is negative 0.5. Look, same thing. Sine cosec tandem, x there and there. In this case, I didn't draw that very well. It should be pi thirds. So this is going to be 2 pi thirds and 4 pi thirds. And let's just say I wanted to check my work there. Cosine mode radian. Cosine of bracket 4 pi divided by 3. And if I really wanted to be sure, I could put a little radian sign on there. Bam! Oh, look! It's negative 0.5. Look at me go. Cotan of theta equals negative 5/4. I say that's a silly question to ask. What I really want to ask is tan theta equals negative 4/5. This one's not one of my unit circle questions. Now, tan will be negative here and here. So if I were to draw that, that's going to look something like whoop, whoop. This would be 4 and negative 5, or 5 and negative 4, depending on which quadrant it is. Just again, using my tan as the y over x. So this one I have to use my calculator for. So I'm going to go tan inverse of negative, actually not negative, tan inverse of 4/5. Try that again. We always want the positive thing for our reference angle. So my tan is going to be 0.67 radians, but I would like it to be actually only in this quadrant. You always want to look at your domain. The domain that they want my answer in is between just 0 and pi. So the only solution I'm looking for here is this one, which is going to be pi minus 0.6747, yada, 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 or 2.467. Now, if I want to check my work, I could say, what is the tangent of that happy little number? Oh, look. It is negative 0.8, which is negative 4/5. Lovely. We can also talk about being an exact multiple of pi radians. Hold on, let me erase that and start again. When we're doing the exact thing, the easy thing to do is to pull the value out. And even if I have an awkward number, I can divide it by pi. Since radians are always going to be something as pi, I can divide that pi out and get that fraction. So using my handy-dandy unit circle, I would say sine theta equals 1/2. Well, that's going to be positive. Sine cosec tandem, my sine is the y. 1/2 is going to be there and there. And that's actually going to be my, didn't draw that very well, 30-degree line, or pi sixth, which makes this 5 pi 6, just off my unit circle. If I want to confirm that, though, I could go sine -1 of 1 divided by 2. Oh, that's a yucky number. But remember, that number represents pi divided by something. So what I'm going to do is divide out my pi. Then I can math frac that number. Oh, it is pi sixths. Beautiful. I still recommend just doing this by using the unit circle. You look at your unit circle, you imagine it in your head, and you play Where's Waldo. Whoop, didn't mean to do that. And then you find the piece that you're looking for. So for this one right here, secant theta equals -√2, what I do is go, oh, what they really mean is cosine of theta equals -1 over √2, which is the same as -√2 over 2 if I rationalize. And then I just play Where's Waldo? Sine, cosec, tanh. Cos is the x, bam and bam. So they're going to be my pi quarters. So 5 pi quarters and not 7. Let's try that again. 3 pi quarters. That's the denominator 4 minus 1 is 3. And here I have denominator 4 plus 1. That's going to be 5 pi quarters. Ta-da! Now again, cosecant theta is undefined. What I really know that means is sine theta equals 0, because this is code for that. So we flip it back over. Sine is 0. When the y is 0, that'll be there, und there, so 0 and pi. And in fact, looking at the domain, also 2 pi, because it is included as a boundary point. I hope that makes sense. Feel free to go back over those things, come and ask Mr. McManus questions, and enjoy.